Okay, you guys, how are you? This is the third part for the videos I'm working. Let's get to work into this. I'm going to share this document so you can see it. For the same reaction we were working before, I advanced with a little bit of increasing the level for this. If you pay attention, as always, whenever you have these types of reactions to stop, you must balance them first. So in the first place, what you're going to do, we said it was 13 potassiums, right? If you know how to balance that yet, I want to teach you how to balance in a future reaction. We have 3 times 4, 12, and also in here 6 times 2, 6 times 2, 12, and that would make it, and 9 sulfurs. Okay, good. If you understand that part, always proceed to read the exercise carefully. Proceed to read the exercise carefully. How are you going to do so? So first of all, by underlining, it says how many, right? How many grams of sulfur monoxide? So you underline that. Sulfur monoxide, right? Escape, so that's what you're looking for. Each time 3.5 moles of KClO3, moles of KClO3. So definitely you're moving from one side to the other, right? From this spot, there. You're moving from here, there. In the reaction, you're moving from KClO3 to sulfur monoxide there. So from 13 moles to 9 moles. That will be your proportion, and then you get started to write the other way around. So let's get to work. You have 3.5 moles, you write that in the first place there. 3.5 moles of KClO3, which what you got. And then let's write the relationship in the reaction from the arrow to the arrow. From the arrow, it says 13 moles of KCl, right? O3, and to definitely 9 moles of SO. That's what it says, my chemical reaction. And it says how many grams. So then I need to transform, until this, everything has been transformed to moles of SO. Now I have to transform to grams of SO. So then you need to put in the lowercase 1 mole of SO. I know it is, right? Exactly 48 grams of SO according to the masses from the periodic table and stuff. Then you just write the conversion factors, right? Well, you just wrote the conversion factors. I'm putting this moment the division, and that would make it, right? And then that would be equals to what specifically, if you insert those values into the calculator, 3.5 times 9 times 48, and all of that divided to 13 is going to be 116.31 grams of SO, right? You can confirm that into your calculators and stuff. Important to remember that something which is important to remember is that this conversion, I obtained it, right, from where? After reading from my chemical, right, reaction. And also the other conversion, I obtained it from where? From the periodic table. Got it? That's important for you to take into account. Okay, let's continue with the other one. It says, if 75 grams, now you have the data in here, of P4S3 react, it's there. How many liters of SO gas? How many liters of SO gas? How many liters? So you're moving from what? 2 grams of SO3, so you write the arrow from here, there. You're moving from here, there. In the reaction, you're moving from what? From this point. I want to use another color so you can see it in a better way. Let's use, yes, let's use this green color, right? Let's use everything in green so you can see it in a better way, okay? I'm going to change everything to, okay, 75 grams it says, right? Okay, 75 grams, 2 liters of SO, meaning that you're moving from here, there, of SO. In the reaction, from here, there. Okay, that's what you've got. So let's get to work. Let's do it. You're right, 75 grams of P4S3. And you must transform. Since it is in grams, you must pass it to moles first. So in the upper part, I know that 1 mole of P4S3 is going to be or the equivalence from the periodic table is going to be, if you add that, 4 phosphorus and 3 sulfurs, it's going to give you 220.1 grams of P4S3. Good. And then now you have that, now you're ready to write the equivalence in moles from the reaction or the conversion factor. My conversion factor in the reaction says that 3 moles, right? I put that in lowercase. Make sure you do that always. 3 moles of P4S3 have the equivalence of what? To 9 moles of SO, because that's what I'm looking for according to the arrows I just put in the upper part. And also, something important for you to understand. Until here, I want to make a little bit of stop, so you have this extra data maybe you didn't have from previous exercises. Look at this. I'm going to divide or write the deviations for the conversion factors and stuff. That's going to be done, and it's going to be done in here. Good. Until this moment, I haven't to moles of SO. I am going to write some equivalences in here. I want you to keep in mind for you. Always, always, 1 mole of any gas, please remember that. 1 mole of any gas, I'm going to put it in here. 1 mole of any gas occupies 22.4. Well, it has 2 equivalences. The first one, 22.4 liters, if it is at STP. What is STP? Standard and temperature conditions. Standard temperature conditions are standard temperature and standard pressure, right? Standard pressure is the pressure at sea level, and standard temperature, when is the temperature 273 Kelvin. Or 24 liters if it is at room temperature. What's room temperature? The temperature we have at this moment at our houses and stuff, that simple one. So remember, with those equivalences, you could have done that easily on the internet. Let's continue with our calculations there. So I was with green. And then, so in the lower case, you're going to put that, then 1 mole of SO, because it is a gas, right? This applies only for gases, by the way. In the upper part, you're going to put, since it says with format STP, then you put 22.4. If it is at room, you would put 24, but always liters of SO, right? So we were missing that for finishing our calculation and stuff with that, and that would make it. And we just put equals, and it's going to be basically done. You multiply 75, right? Times 1 times 9 times 22.4 divided, open parentheses in the calculator, to 220.1 times 3, close parentheses, and then equals. Okay? It says 22.8899 liters of SO. I always prefer to use 3 decimals in chemistry. Others, they use 4 decimals. Yeah, I think it's wise to use the 3 or 4 decimals, because sometimes when you round them, at the end, when the final answer, you could commit some mistakes, or maybe I not the answer you're looking for. You have to be that precise in analytical chemistry. For part C, you would have only just to try to, sorry, yes. In part C, I wanted to underline this, the same thing we did before, right? I want to use another color so you can see it in a better way. I want to use maybe, yes, this blue. Okay, how many, it says how many grams? How many grams of potassium? It is grams of potassium chloride you're looking for. That's what you're looking for. And you're moving from 0.2 grams of KClO3, right? So definitely you use the arrow, you're moving from here to potassium chloride, okay? In the chemical reaction, so we're moving towards KClO3, yes, from there to where? To potassium chloride, from KClO3 there. Hope you're following the idea. I want to design here, there, from here, there. So there we're going to perform the calculations to do, right? So I want to use the blue color. So, okay. And then write what you have, 0.2 grams of KClO3, right? And then you've got the part. After that, you will just have to transform. Since you have grams, make sure you can transform that to moles in the first place, because we've got the numbers there. The coefficients from the balanced reaction represent moles, so you must pass the grams to moles in the first place. Okay, so then in the upper part, I know that 1 mole of KClO3 is going to be representative. You add the masses from the periodic table, potassium, chlorine, and 3 oxygens, you're going to get 122.55 grams of KClO3. Good. And you're good to go. In this moment, you just passed the moles of KClO3 to the grams, sorry, to moles. Now let's pass the moles to what we were looking for. So my proportion says that 13, right, moles of a KClO3, right, are related to 13 moles of specifically uh, moles of KCl. See, the ratio is 13 to 13, and then you continue working because the question was how many grams. So now let's pass the moles of KCl to grams. So I know that 1 mole of KCl, right, has the equivalence in grams into 74.55 grams of KCl. Got it? Now I'm just going to write the divisions for this conversion factor so you can understand it in the better way. Right? Okay, so those are the conversion factors you're supposed to do into your notebook or whenever you do some calculations. And I wanted to just, well, I'm going to use the red color so I can cancel. Okay, pay attention to what I did. I moved from grams, and you put grams in the lowercase so they cancel because those are fractions. You're multiplying fractions, right? So moles of KClO3 with moles of KClO3, moles of KCl with moles of KCl, and at the end, my answer is going to be only in grams of KCl, which is potassium chloride, which is what you're looking for at this moment. You insert those values into the calculator, you put, right? You should put something like 0.2 times 13 times 74.55 divided to open parentheses 122.55 times 13 close parentheses and then equals. Remember that. And 0.122 it says grams of KCl. Always put the answers in the units in the answers, and that would make it. Okay, my dears, that was it. I hope you're taking notes about each of the processes, and that would make it. So that was it. Thank you. Thanks for your attention, and we will continue.